circle in coordinate geometry. Once we see an equation of the circle given to us in the exam question, first thing we do, we open our maths table to formulas that has to do with circle in coordinate geometry on page 19, because we're going to need them like 100%. Okay, let's just take those and see what we need to do here. So we have equation of the circle, and we have to write down the center and the radius of circle K. So something that is there almost every time in your exam. In our maths table, that's the reason why we needed the formulas. Here we have that when equation of the circle is given in this way, then the center of that circle is HK. And where is HK? That's this number here in bracket together with X, and K is in bracket together with Y. And then we have radius is letter R, so that's our radius. So then we have a look at our specific example. So here we can see that in bracket with X, I have 5, so therefore that will be my H. So that means the first coordinate of the center will be 5. And then the next one we can see is 3. Now, the problem we are having here is that minus. Look at that. In your formula, you have a minus, but here you have plus. So what happened here? So the only time the minus become plus if we had minus and then minus a number. And that way the two minuses will become plus. So that means that K was minus 3. So therefore, minus 3 is the second coordinate of the center. And then the radius. So at the end here, radius is in the taken to the power of 2. So that means my 25, that is radius to the power of 2. And when we are looking for radius, not radius to the power of 2, to eliminate that power of 2, what do? We take a square root of the other side. We put that in the calculator, and we get that the radius is 5. So there we have center and the radius. Let's have a look at second part. So second part, use algebra to investigate if the point 9 and 2 is on, inside, or outside the circle K. So the three situations that we are having here, so let's just get 3 different circles. So I can have that point on the circle. So meaning, let's say I have a point here, has coordinates 9 and 2. So that's one situation. The other situation could be inside the circle somewhere, 9 and 2. And then another situation is that that point could be outside of the circle. So I need to investigate, well, where is it? Now, what tools do I have? In this particular case, we do have the center and the radius. Now, we use the idea of the radius to find out about that point, because from the center of the circle to the edge, we have radius. The same idea will be here, and the same idea will be here. Therefore, in coordinate geometry, one of the things we can do, we can calculate length. So here, the length or the distance from that point to the center. So if I am looking at a distance from my point, 9 and 2 in this case, to the center, and the center that we found earlier, 5 minus 3, 5 and minus 3. So if that distance is the same as the length of the radius, then indeed that point is on a circle. And let's not forget that radius is 5. If that distance from the center to the point is less than 5, then it is inside the circle. And again, in this case, if that distance from the center to the point is more than 5, therefore it's outside. So in order for me to actually know which option is true, I need to calculate the distance or the length from the point to the center. How do we do that? We go to our maths table, and page 18 here we have the second formula is the formula for the length. So what do? We write down that formula in our exam, and then we have to replace the letters with numbers. So when I'm doing coordinate geometry, I like to do a list so that I don't mix up my values because it's very easy. Now, it doesn't matter which point is first, which one is second. So let's say my point 9 and 2 is the first point. That's the reason why we have 1 and 1 here. And then the center, 5 and minus 3 is my second point. That's why we have 2 here. So now let's replace our letters. So bracket x2, my x2 is 5, minus, then x1 is 9, close bracket, don't forget about power of 2, plus, again open bracket, y2, my y2 is minus 3, minus, and then y1 is 2, so 2, let's extend that, close the bracket, and again, let's not forget about power of 2. And all we do, we put that in the calculator, press equal, and we get is 6.4. That's the length. So that means it's actually outside of the circle because that distance is longer than 5.